Chapter 14 Basic Electricity and Electronics. In this video, we'll be looking at resistors and capacitors. The purpose of using resistor is to limit the amount of current flowing in a circuit so as to protect the components from being damaged by too much current. For example, if a LED works at 2 volt and was connected directly to a 9 volt battery, the LED will burn out quickly. Therefore, to protect, a resistor is used to reduce the amount of current flow. Resistors are made with different values. The higher the value, the greater the resistance. Resistance is measured in ohms or sometimes in kilo or mega ohms when there's a larger resistance values. To make it simple, we can treat a resistor as a rock. Imagine in a river there's a huge rock blocking in the middle, and this limits the amount of water flowing through. However, if the huge rock is replaced by a smaller rock, the amount of water flowing through will increase. Therefore, the bigger the rock, the lesser amount of water flowing through. Similarly, this applies to the resistors. Since the resistor is used to limit the amount of current flowing in a circuit, the higher the resistor's value, the amount of current flowing through will be lesser in the circuit. Notice on the resistor, there are different color bands. These color bands are coated on the resistors to show their values. But what does each color band represent? The very first 3 color bands shows the resistor's value in ohms. The first band gives the first digit. Second band gives the second digit. And the third band indicates the number of zeros. As for the fourth band, it is known as the tolerance band that shows the tolerance or accuracy of the resistors. To read the color code of the resistor, we need a resistance table. Basically, this is the resistance table whereby the first column shows the value of the first color band, second column for second color band, third column for the third color band, and lastly, the fourth column for the fourth color band, also known as tolerance band. Let's try out a few examples on how to read the color codes using the resistance table. One important thing to take note: when using small value resistor that is less than 10 ohms, the standard color code cannot show values of less than 10 ohms. Therefore, 2 special color codes are used for the third band to show small values. They are the gold, which means times 0.1, and the silver, which means times 0.01. To make it simple, let's look at some examples. Moving on to the connection of resistors, there are 2 ways in connecting a resistor. When 2 resistors are connected in series, there's only one way for the current to flow. Hence, there is same amount of current flowing through each resistor. To calculate the total resistance of the circuit, Simply add up the values of the two resistors. The combined resistance will be greater than individual resistance. When two resistors are connected in parallel, the current splits at the junction. Hence, there's different amount of current flowing through each resistor, and the amount of current flow is dependent on the resistance. To calculate the total resistance of the circuit, you have to take the reciprocal of the two resistors and add up the values. The combined resistance is less than the value of an individual resistance. Lastly, the most important part for resistor. When we mention about resistor, we can never forget one important law, which is the Ohm's law. In order for the current to flow through a resistance, there must be voltage across the resistance. Therefore, Ohm's law shows the relationship between voltage, current, and resistance, whereby voltage is equals to current times resistance. Now, let's move on to capacitors. What is a capacitor? A capacitor is like a rechargeable battery whereby it stores electricity. When capacitor is connected to a battery, the current flows into it and charges up. The amount of charge stored in a capacitor is known as capacitance. Capacitance is measured in farads, and the higher the capacitance, the more charge it stores. There are two types of capacitors: electrolytic capacitors and non-electrolytic capacitors. The difference between the two capacitors is that the electrolytic capacitor has a leg marked negative on them and must be connected to the negative terminal. As for the non-electrolytic capacitor, it can be connected either way round. Now let's look at the summary. In terms of resistor, you should know the purpose of using resistor and be able to read the color codes on the resistor based on the resistance table. Next, recognize how resistance varies when resistors are connected in series and parallel, and also understand the Ohm's law and apply the formula. Moving on to capacitor, basically is to get an idea of what capacitors are, the unit to measure capacitance, and the types of capacitors available. That's the end of the video. You may now proceed to the next section.